Welcome students. Today we will be dealing with the dielectrics. What will happen when a dielectric is placed between the two parallel plates of a parallel plate capacitor. So in the last video we have learned that the capacitance of a parallel plate capacitor is given by epsilon 0 A by D provided the space between the two parallel plates is vacuum. And if it is some dielectric means an insulator like paper, mica, anything can be oil, all those things are dielectrics. So if you place a dielectric in between the two parallel plates, if this is two parallel plates, if you introduce some dielectric in between them, then the capacitance will increase by k times epsilon 0 Ka by D, where K is called the dielectric constant or relative permittivity. You can write epsilon R also, no issue. So today we are going to learn how that capacitance will increase. Capacitance will increase, that if you compare it with water tank, the height of the water tank is increasing or the volume of the water tank is increasing. When you add something, the volume automatically increases. That is not possible in water tanks, but in capacitors, in case of electric charges, it is possible by introducing a dielectric in between them. How it happens? So we have to know what is happening there. How the capacitance will increase when a dielectric is introduced in between them. So to understand that, we have to first learn what is a dielectric. Dielectric is an insulator, and there are two types of dielectrics. One is called a polar dielectric. Polar dielectrics. And second one is non-polar dielectrics. So let me say what is the difference between these two. See, all the what is the speculative dielectric? Dielectric is a insulator. Insulator means there won't be any free electrons. All the electrons will be strongly bound to the nucleus of the atom. It cannot be, by attaining some energy, it cannot escape from the atom. It cannot be a free electron. So normally these atoms will combine to form a molecule. When they combine to form a molecule, say for example, there is one molecule, here there is another molecule, here there is here there is one atom, here there is another atom, here there is another atom. Imagine like that. And these atoms will be bound together to form a molecule. Suppose this atom is having, say, one proton, like hydrogen. Suppose this is having 8 protons and this is also having 8 protons. So this is the positive charge and this is positive charge and this is the positive charge. These are bound together so that, see, center of the positive charge will be somewhere here. If these were not there, the center of these two positive charges will be this one, center of this one. So since there is a small positive charge here, the center of the positive charge will be somewhere here. And there will be electrons around it. There is a cloud of electrons here, there will be a cloud of electrons here, there will be a cloud of electrons here. And electrons are negatively charged. And if you consider that negative charge alone, see, sometimes the negative charge in the center of the negative charge also will coincide with that point. In some molecules, the center of the negative charge will be somewhere here, and this will be the center of the positive charge. Understood? So there are certain molecules like that. So in that case, for example, water is a typical example for that. Water molecules, it is having some polarity. Its center of the positive charge and the center of the negative charge won't coincide. So this molecule, electrically, it will behave as a dipole. This molecule will behave as a dipole. It will have its own dipole moment because the positive center of the positive charge and center of the negative charge won't coincide, because they will be slightly distributed in a different manner, so that not in exact spherical manner. So what will happen, there will be some polarity. So this type of molecules are called polar molecules. So if a dielectric is made up of such polar molecules, it is called a polar dielectrics. What is the peculiarity of polar dielectrics? It will have a polarity. The molecules of the polar dielectrics will have a polarity. It will behave as a dipole. Okay. And if you take a dipole, this dielectric with the polarity, with the polar dielectric, the molecules will be distributed like this. In the random manner. This may be plus minus, maybe plus minus, this may be minus plus, like that. In the random manner it will be distributed. In the random manner it will be distributed. Okay. So all the molecules will be having it will behave as a dipole, and it will be having a dipole moment. So that is called polar dielectrics. There are non-polar dielectrics. In non-polar dielectrics, the center of the positive charge and the center of the negative charge will coincide here. So there won't be any polarity. So the molecules will be like this only, plus and minus here. So there won't be any polarity. It won't behave as a dipole. In such cases, it is called non-polar dielectrics. So in non-polar dielectrics, the molecules will be distributed like this, without any charge. Now, what happens, the interesting thing is what happens when it is placed between in an electric field. When it is placed, this dielectric, when it is placed in an electric field, what will happen? You have seen what happened in my previous video. I told you what happened when a conductor is placed. When the conductor is placed, there will be a drifting of electrons, and there will be internally there will be an electric field, so that the electric field inside the conductor will become zero. That happened because the electrons are free to move in case of conductors, but in dielectrics electrons are not free to move, so they cannot polarize in such a way. But one thing will happen. If you introduce a non-polar dielectric, it will be like this. Without any electric field, it will be like this. But once you introduce this dielectric in an electric field, what will happen is, say, suppose this is the electric field. Now what will happen to the molecules is, there will be an attraction towards the molecule itself. The center of the positive and negative charges coincided in non-polar molecules. But when it is exposed to the electric field, there will be a small polarization. So the atoms will behave like this. Suppose this is the direction of electric field, this will be positive. The molecules get little elongated, I can use that word, little elongated. So non-polar molecules will get a little elongated, so that there will be a small polarization. Not that entire electrons will move like that, not like that. There will be a polarization. The molecules will get a little bulged, so that the center of the negative charge will shift towards this and center of the positive charge will shift towards this. Like that the molecules will get arranged. So here it will be plus and here it will be minus. Now what will happen is, due to this, what will happen is, imagine this side. There will be an accumulation of positive charge this side and there will be an accumulation of negative charge this side. Okay, all the other will get cancelled. Here in this side there will be an accumulation of negative charge and here there will be a small accumulation, very small accumulation of positive charge. And what will happen if such thing happen? The electric field, there will be an electric field in this direction. There will be an electric field in this direction, internal electric field, and that is very feeble, that is very small. That internal electric field, when compared to external field, E will be very small. In the case of conductors, what will happen? The electrons will drift and both the electric field will become equal and the internal electric field become 0. Here that is not the case. Here what happens is, suppose this electric field is E0 and the internal electric field E, the electric field inside the conductor, inside the dielectric will be E minus E0. Oh, sorry, E0 minus E, because E0 will be greater. So that is the peculiarity of dielectric. If you place a non-polar dielectric. If you place a polar dielectric, the same thing will happen. There will be, all the polar molecules will get aligned in such a way that it won't be not much strong. The electric field inside the formed E, electric field formed inside is E, that will be bit weaker than non-polar dielectric. So usually we use non-polar dielectrics. It is having its own reason. That is not, it is beyond your syllabus. So when you go to higher classes, you will learn why the non-polar molecules are having a low internal electric field. Now you have to understand only this thing. There are two types of dielectrics, polar dielectrics and non-polar dielectric. When it is kept in an electric field, there will be a slight polarization, and due to that polarization, and small internal electric field will be generated, and the total electric field inside the dielectric will be less than our external electric field E0. So it will be E0 minus E. Understood? Now let us see what will happen if you introduce a dielectric inside between the parallel plates of a parallel plate conductor. Let us see what will happen if you introduce a dielectric, if you place a dielectric in between two parallel plates of a parallel plate condenser, capacitor. See, imagine that these are the two parallel plates and its charge is Q in this plate. In this plate it is minus Q. If A is the area of the plate, and D is the distance between them, then what will be the electric field in between these two? E will be equal to sigma by epsilon 0. That is that we have proved in the last chapter. That will be the E. Now imagine that you are introducing, and from that we will get V will be equal to E into D, and that will be equal to sigma by epsilon 0 into D. But what is sigma? Sigma is equal to Q divided by A. It is the charge per unit area, that is Q by A. So V will be equal to Q by A epsilon 0 D. I am replacing sigma by Q by A, that I have shown in the last video. And what will be C? C will be equal to Q by V, and that will be equal to Q divided by QD by A epsilon 0. and that is equal to epsilon 0 A by D. That is how we got that formula. Now let us see what happens when a dielectric comes. Now you imagine that it is fully filled with a dielectric of dielectric constant K. What will happen? Now what will be the E electric field? E will be equal to sigma by, instead of epsilon 0 you have to use epsilon 0 K, because this K is the relative permittivity of the medium, that is equal to epsilon R. So E will be equal to sigma by epsilon 0 epsilon R. So I am writing it as K. Instead of epsilon R, I am writing it as K. Now what will be E then? E will be equal to, sigma is always Q by A, so Q by A epsilon 0 K. This is E. Now what will be V? V will be equal to E into D, that is equal to Q into D by A epsilon 0 K. And what will be capacitance? Capacitance is Q by V, and that is equal to Q by QD by A epsilon 0 K. So C will be equal to epsilon 0 K A by D. That is what is I am written. Epsilon 0 K A by D. That is how that relation has come. What happens is the electric field will become reduced. What happens when the electric field will become reduced? You can add more charge. See, what will happen if you charge it more? Imagine that it is air inside it. You have to understand it thoroughly, that is I am repeating. Suppose you are charging it fully, positively charged Q, 1000 lakhs, crores of charges. And initially what I said earlier in the earlier video I told that when the charge increases, what will happen? It is having a capacity, this plate is having a capacity, so it will start to discharge. So that discharge happens because the electric field intensity is getting more and more. When you charge, the electric field intensity E will also increase. As E increases, what will happen? The force acting on unit positive charge will increase. That is, there will be a discharge. So if you can somehow reduce this E, suppose you are having 1 lakh charges here and having a particular E. If you can hold the same charges here and reduce E, then you can add more charges. Suppose E is reduced to half, then you can add a 2 lakhs charges. That is what is happening when you are adding a dielectric in between them. When you add a dielectric, the electric field intensity will get reduced. As the electric field intensity reduces, the probability of shorting or the discharge will be reduced. So you can add more charges. That is equivalent to adding the height of the water tank. You are having a water tank like this, and when you add a dielectric, what really happens is you are adding the height. It is similar to that. So its capacity will increase. That is what is happening. Now the one important thing that is usually in entrance exam they will ask questions from this. Here I have added the entire distance D is filled with the dielectric. Now the capacitance is epsilon Ka by D. Now what will be the situation if I add a thin piece of dielectric in between? Imagine that I am adding a dielectric piece of thickness T here. This is the dielectric, and balance is vacuum. Not entire D, entire thing I am filling with dielectric. I am keeping a slab of dielectric of thickness T in between the plates. Now let us see what happens. Now what will be the electric field now? E will be here. See, here it will be E0. Here also it will be E0. Here it will be E, and E will be different. Okay, understood. See, here it will be E0, here it will be E0, and here it will be E. To understand it more easily, imagine that dielectric is kept like this. This thickness is T, and this is the dielectric. So this is total distance is D. So this will be D minus T. Now it will be easy to understand. Here the electric field will be E0. Here the electric field will be less than E0, that is equal to E. So in this case, here the electric field will be E0 and here it will be E. So you can understand easily. The same is the case here. Here the electric field intensity is E0. Here the electric field intensity is E0. Here the electric field intensity is E. Now what is the total electric field? Total electric field will be a combination of these two. Now what will be the potential? Suppose E is the electric field here. Now what will be the potential? Potential will be the work done in moving a positive charge from here to here, from here to here, again here to here. So three regions are there. So here to here I have to do E0 into this thickness. Here also E0 into thickness. Here E into this thickness. Or in this case it will be easy. If I have to bring up a unit positive charge from with this plate to this plate, or in the reverse manner, whatever it is, I have to do this work E0 into D minus T. Then I have to do E into T. So total work done will be equal to E0 into D minus T plus, what is E? E into E into T. Okay, but what will be the relation between E0 and E? E0 and E. What is E0? E0 will be equal to sigma by epsilon 0. Then E0. What will be E? E will be equal to sigma by epsilon 0 K. So E will be equal to E0 by K. E0 is sigma by epsilon 0. E will be equal to sigma by epsilon 0 into K. That is, electric field intensity will decrease. So the relation between E and E0 is E will be equal to E0 by K. So I am writing V is equal to E0 into D minus T plus, instead of E I am writing E0 by K. Now this is the potential between the two plates. Now by introducing a dielectric, the potential has changed to this one. Otherwise it would have been E0 into D only. Now it has become E0 into D minus T plus E0 into T by K. Because I have to do these two type of work. One is E0 into D minus T and another one is E into T. That E is equal to E0 by K, that we know. Now that V will be equal to, we can take E0 common into D minus T plus T by K. Now what is E0? What is E0? E0 is equal to sigma by epsilon 0. If this was not there, E0, entire thing will be E0 and that is given by sigma by epsilon 0. So V will be equal to sigma by epsilon 0 D minus T plus T by K. T here I can take common, but presently I am not doing that. Now what is sigma? Sigma will be equal to Q by A. So I am putting it, V will be equal to Q by A epsilon 0 d minus T plus T by K. Now what will be C? C will be equal to Q by V. You have to follow it, write it down. Along with me you write. Q by V, that will be equal to Q by A epsilon 0 d minus T plus T by K. Q and Q will get cancelled. A epsilon 0 will come up. So C will be equal to A epsilon 0 by d minus T plus T by K. This is the capacitance. If you introduce a dielectric of thickness T in between them. So C will be equal to A by epsilon 0 d minus T plus T by K. Now, as a special case, you imagine that T as the thickness of the T I am increasing and it is coming to D. Suppose T is equal to D, that is you are filling the entire thing with the, then what will be C? Special case. Special case when D is equal, when T is equal to D. What happens when T is equal to D? C will be equal to D minus D, that will be 0. A epsilon 0, instead of T I can write D. This I will write D minus D plus D by K. D minus D is 0, that will be equal to A epsilon 0 by D by K. And that is equal to, C will be equal to epsilon 0 K A by, or A epsilon 0 K A by D. That is the thing I have written here. Same thing. So if a special case comes that T is equal to D, you will get epsilon 0 K A by D. That is the problem. Now this you can write in this way also. This can be written as C is equal to epsilon 0 A by, you can take T here, D minus T into T outside, this will be 1 minus T, 1 minus 1 by K. This can be written in this way also. That is D minus T into 1 minus T, D minus T. Minus T into minus 1 by K is plus T by K. You can write in these two methods also. So when you take the special case, you have to take this formula. Then D will be equal to, T will be equal to D. So D minus D by K. So these two will become 0 and it will come to this formula. Okay. Please note down. Next we have to learn what is the energy stored in a capacitor. That we will learn in the next video. So if you like this, if you have liked this video, you please subscribe and press that bell button. Okay. Thank you very much.